Hello everybody, thank you all for coming. I'm glad so many of you decided to come here. You sure there's another session downstairs, you know that, right? Cool. So yeah, as Gwen said, I'm Joe Stead. Follow me on Twitter if you don't already, it's a great laugh. So yeah, Kubernetes and testing. I went for a full hipster title, because why not? So I have a bit of a confession to make about Kubernetes. About 18 months or so ago, I was having a beer with somebody in Oslo, and we were talking about Kubernetes, and I was there saying, we don't need it, it's all this hipster nonsense, it'll be dead soon, forget it, what the hell is the point? And then I began to evaluate life without Kubernetes, and I weighed up the pros and cons, and realized actually, maybe life with Kubernetes is a good idea, and I did something that the British government may or may not do. I changed my mind on it, and decided that actually I'm going to stay with Kubernetes and run with it. So if you're on the fence about what Kubernetes is, and if it's a bit too hipster for you, try it out. It does actually solve problems. Anyway, let's begin. So I've come up with a few kind of guidelines for the talk that hopefully will make the talk better for you and better for me too. The first one is, if you're confused by something I say, just shout out and ask so I can clarify for you. It makes everything so much better, not you, Matt. It makes everything so much better for everybody involved. If you're confused, somebody else is. If you have a question, ask. If you have a question, think it's stupid. It's not stupid. Ask anyway. And if you don't feel comfortable, I'm around all day. Come chat to me afterwards. It's fine. Yeah. Please take pictures, and please tweet those pictures at me so I can see them. Anyway, to start with, what I want to do is kind of define a project that hopefully is familiar with a lot of you here. So it's a web project, first and foremost, and it looks a bit like this. We have a web server and a database, and that's it. But of course, it's 2018, so we need more moving components, we need more databases, we need a cache, a queue probably, and some things running out of process. Does that look familiar to everybody here, that sort of diagram? Yeah? Good. So that's the sort of thing that we're going to look at testing. And then we need to decide what sort of tests we want. So I did one of these. Now, I realize this is a testing event, and lots of people have opinions on this pyramid. First off, it's not a pyramid, it's a fucking triangle. Secondly, go talk to somebody else. Not interested, go talk to somebody else about it. But you get the idea. The bit I want to talk about mostly is kind of this side of things, and even then people can't really agree what these mean. So I'm looking kind of tests from an API point of view and a UI point of view. So that's what we're looking at automating. Everybody on the same page? Good. So the problem we have is when we want to run our API tests, UI tests, end-to-end tests, whatever you want to call them, we tend to have to configure the test instance, run the test, reset the test instance, go to the next test. And it takes quite a long time. I sped up this animation by 4 times because it takes too long. But you get the idea, it's really painful. And that's kind of slow, and it can take days to run your full test suite if you do it that way. So I wanted to kind of not do that. I wanted to do this. So I wanted to do things in parallel. So we create a new instance, we run the test, and we delete the instance. And everything happens really quickly. So we don't have this do one thing, wait for another thing, do another thing. Do everything at once, way quicker. The problem with that is if you're running on cloud platforms, you have to wait for things to be provisioned in the cloud. If you're running on premises, you have to buy more servers. There's loads of barriers to entry to doing this sort of thing. And it's not particularly easy, unless anybody else has any other solutions. Good, you're in the right talk. So, how can we achieve this? Who here knows what Docker is, out of curiosity? Who has never heard of Docker? Good. Who's never heard of Kubernetes? Cool. I'll tell you what it is, don't worry. So the first solution we looked at was using Docker for this. So essentially we had our test code that would speak to Docker and then would spin up an instance. The problem is, our defined problem, if you like, has message queues, a distributed cache of some kind, multiple databases. So actually you end up spinning multiple containers that all need to talk to each other. So your test code is suddenly in charge of at least 3 containers in this example, but probably way more, and it gets really messy really quickly, especially if you're running these in parallel. So Docker doesn't really work for us. And this is where Kubernetes comes in. So for those who don't know what Kubernetes is, it's a Docker container, well, it's not even Docker container, it's container orchestration. So if you have your container in Docker, or you have your container in one of the other ones that doesn't really exist anymore, but there are others that people sometimes use, apparently, I'm told. You can kind of host it in Kubernetes, and that will handle resiliency, so if your container dies, it can restart it, can handle scaling, can handle all of this wonderful good stuff, and you don't have to worry about it. So we're taking all of these moving parts, so the 3 containers we saw before, and sticking them in Kubernetes and letting Kubernetes manage all of that for us. Okay, really quick overview of what Kubernetes is, because I don't really have time to go into much more detail, but we'll get there. Oh, I did this talk at SwanseaCon, so I put some swans in. So there's lots of moving parts to Kubernetes. So many, in fact, that I eventually got bored of listing them on the screen. There's loads of bits of Kubernetes. Too much to go to in this talk. We're going to kind of take a subset of these and discuss pods, deployments, services, and namespaces, and how we use these specific parts of Kubernetes to automate our testing. Okay? So, essentially, a deployment is a defined application that has a container in it. So a deployment will have some config in there through environment variables and the like, and through that we'll create pods. So pods, think of as your Docker container. Okay, it's not quite the same, but they're kind of almost synonymous enough for the purpose of this talk. Okay, so a deployment can have multiple pods if we're scaling things out, and not all of these pods have to be the same. The deployment at the top there, I ran out of space to draw more pods onto the slide, but that will have pods too. Everybody on board with what a deployment is and pods are? Cool. Now the service is how you can communicate with those pods. So if I have my out of process message queue thing, and I need to send a message to it somehow using HTTP, for example, what I'll do is I'll call a service that will map to a pod that belongs to a deployment. Okay? So it's a way of discovering things in the Kubernetes cluster. That sort of makes sense? Anybody super confused? So the service is a generic name for your backend, for example. So instead of calling a particular server, you'll call the service, and that will resolve the request to the relevant pod. Okay, we'll see this later in action, so hopefully it'll all fall into place then. And then one thing that glues all of these together is we can stick them into a namespace. So a namespace is kind of what you'd expect it to be. It's a way of grouping everything together with a name. It's quite well named, I think. And this is where we actually get a lot of simplicity. So we've gone from having Docker deploying, or our test code deploying multiple Docker containers and managing the network, to our test code having to think in the form of a namespace that has everything in we need. So we've gone from managing multiple things to managing one thing. And we can have multiple namespaces running in Kubernetes at the same time. And they've got a unique name each, because they're namespaces. Make sense? Perfect. So Kubernetes really helps us here because we can cluster our hardware together. So previously with our Docker example, we would have our test code talking to Docker, and that would spin up containers. That would be on one server. In Kubernetes, you can have multiple servers, and they're all clustered together, and they all talk to each other. So you'll deploy an instance of your application to Kubernetes, and that can go across hundreds of servers if you configure it that way. In this picture here, those are a set of Raspberry Pis. So if you have budget constraints, that costs about £200 to set up, and that can run your testing for you and sit on your desk. I prefer this version, which has flashy lights. So what we have here is each one of these flashy lights is indicating a different state of what's going on in the cluster. Don't worry too much about it, but it's a really cool way of visualizing what's going on, and also, if you work in an office, distracting everyone around you. So how does the clustered hardware kind of work? So essentially, we have a control node, line breaks, and lots of nodes around it. So we have one node that kind of manages all of our other servers together, okay? And we can join more and more to this cluster as we go. And what we actually might have is part of namespace 1 on one node, part of namespace 1 on a different node, but they'll still talk to each other and they'll still work. It's still the same application split across multiple nodes, yeah? And then when we realize actually we're running out of power, just add more nodes, and then we can add more things in. Another cool part is shared test dependencies. So we can have part of applications across 4 nodes in this example, and say we want to use something like Selenium Grid for our UI test. That can be deployed into Kubernetes as well, and that will be spread across the entire cluster as well, which is pretty cool. It's something we actually do. I'm not selling you snake oil here. I actually do this at work. It works. Okay? So we deploy Selenium Grid to our cluster, and then that's shared between all of the dependencies too. And then all of our applications happen to use an instance of OpenLDAP, so think Active Directory. So again, we deploy Open LDAP to the cluster too, and all of the deployed instances will use that. So that's just a kind of a read-only state of users that we import to every application. Make sense? Cool. Now, this isn't really a benefit of using Kubernetes for this. It's just kind of an added side effect. Because Kubernetes is distributed, you don't really want to be writing your logs to the server it's on. You want to write those logs into a centralized place. So you kind of see this in any distributed system. This is just free with Kubernetes because it's distributed by nature. So all of the logs of everything that's running in that cluster gets sent to one place. Okay? That means our application logs. So if we're deploying many versions of our application and running different tests against them that produce logs, they're all getting sent to one place. Okay? Which really opens up some pretty cool opportunities for some exploratory testing. Because we're not just running something, tearing it down and creating a new one. We're actually sending the output of that in the form of logs to somewhere. So this is, again, a true story. Our logs at the company I work for contain audit actions. So we know how many users are doing what actions and things like that. Our application has three types of users. There's an admin user, a simple user, and then there's a user with elevated privileges. Okay? So because we sent all the logs in one place, including our audit logs, I was able to chart this out a little bit. Now, there's two colors there. The purple is admin, and the green is a user called April Moore. So this is against every single test that we've run against this cluster. So there's potentially hundreds of tests being run here, all doing different things. Can anybody spot the problem? There's only two colors. We have three types of users, and we're only testing two of those in all of our tests. So we have the admin user, which obviously can do anything, and then we have April. Now I know, because we're using a shared Open LDAP instance, that April is the first user in there, because her name starts with A, and the first user in that instance we elevate. So all of our tests were running against an admin user or a user with elevated privileges. No simple users were being tested. Good tests, right? But by using this, having our logs curated in one place, we're able to identify this and realize that we need to fix it. I want to say fix it, but we haven't done it yet. I don't want to lie to you. So there were some tests that were using ordinary users, which was great, but not enough for us to have real confidence that the majority of our users actually were being tested against. So I'm sure, as you are all test professional people, that you wouldn't do such an amateur mistake like this, but it happens, and we spotted it because we were able to bring everything into one place. You can also see what's happening in real time as well. So this is kind of just like a bonus for having a dashboard against a TV in your office of seeing what your test cluster is doing. But actually what you can see is you can see these here are unavailable pods, and these here are available pods. You can see a dip here that correlates with this one here. So you can see as test cycles are recycling when we have a big dip and a big increase, things like that, which is, whatever, not particularly too interesting, but you can see how they're spread across all of the nodes too. That's fine, but it gets way better when you can have performance stats from that. So although you're not doing any performance testing, I can see that I'm using 5 gig memory, I'm using this much network traffic, the CPU stats here and things like that. If I commit something that balloons the memory usage, although I'm not testing explicitly for that, I can see it happening. I can see yesterday we're averaging 5 gig memory on the cluster. This week we're averaging 10 gig. What's happened? It gives us that visibility for free. Performance testing is really difficult, especially regression performance testing. This isn't the perfect solution, but it's a free solution as a side effect of this. Make sense, everybody? Good. Another really kind of benefit of Kubernetes is there's one control point. So traditionally, when I was managing our tests on the different servers that we had, I had to SSH into them one by one, or for Windows users, remote desktop in or whatever. Kind of annoying. Luckily, I had my key in there, so it was easy enough to do, but I still had to do it one by one. With Kubernetes, I can kind of do it all centrally. One command affects everything if I need it to. So I save that kind of administrative overhead of having to use individual servers, when actually I can just talk to Kubernetes and it will figure it out for me. So, nice little free benefit. There is a problem with doing that though. So that wasn't a dramatic pause, I was just thirsty. So calling Commandline Tools from test code is easy. It really is easy. you can do process.run command and it will run it. Except if it doesn't work, then it becomes really difficult to parse the error. kubectl, the command you saw before to access as a control point for all of our cluster, is essentially a wrapper around the HTTP API that Kubernetes gives you. Okay? Calling HTTP from any code is really easy. We probably already do it in our test anyway to talk to our own APIs or our own UI. We're probably making web requests of some sort. And when they don't work, we get a status code in the 400 range, potentially 500 range, and a parsable error, hopefully, that we can figure out, report to, and do something about. We've actually got something that we can parse from code. We've got something that makes sense from us as writing these tests as well. Yeah, so that slide where I had all of the components on there, that was like less than half of them. There's so much to Kubernetes, it's really quite complicated. And our tests shouldn't need to know about that. So going kind of a little bit deeper, the kubectl tool it uses some YAML files, which are kind of configuration of what we're going to deploy. Okay? I don't want my tests to know that they're using YAML files somewhere. I don't want my tests to know that it's even talking to Kubernetes. My tests are my tests. I should be able to say, give me an instance, test against this instance, delete the instance. That's all I want my test code to do. So that's kind of what I end up doing in the end. So we have our test code. It talks to a HTTP API, which could be something you make yourself, that grabs the relevant config files and posts those to Kubernetes. And eventually we get a URL back to our test code. And we can use that to test against. Okay? I'll show you it instead, if the Wi-Fi works. That won't. Cool, right, so. I can see here if I send a request. Can everybody see this, by the way? Do I need to zoom in more? Very good. See this, I can see things that I've deployed to, how do I get rid of this? In this tiny window here, I can see things that I've deployed. So we can see there's lots of things going on at the minute. This, for the record, is actually being used at work. It's a Tuesday. There are people at work running against this. So if anything goes wrong, blame my team, not me. Screw them, they're not here. They can't defend themselves. What I'm going to do now is I'm going to create an instance. I'm going to create an instance of CM, which is what the product is called, Conference Manager. I'm going to give it a tag so I know who owns it, and I'm going to give it a URL of a Kubernetes cluster that I want to talk to. I'm going to make that request, send it. I have a meeting in 15 minutes. Oh, it has sent it. It's body here. Get a tool and create it back, and a header with this here, which is a location header. If I make a new request, I can get details about that deployment, including that the application has been deployed here, which means if I go back to my browser, so that's going to take like maybe 30 seconds or so to load, so I'll just give it a second. What we've done there is we've deployed Postgres, RabbitMQ, Redis, and about 6 or 7 of our own processes that we've created. Yes?
You've got time for a dumb question.
Yeah.
Postgres is clearly a database technology.
Yep.
What about the data?
I don't care about it. I'm not assisting it.
So it deploys with some data in?
Yeah.
In other words, your test data is part of that container?
No, not necessarily. What we have here is what we'll have is a blank application with no users or anything in. What we do as part of our setup in the test code is run an import of users and things like that, but that's hidden away somewhere else. So if I make a request to oh, there's so much to delete. I don't normally have to twist my neck like this, it's normally much easier. So if I make a request to our API there, I will get a 401, and that's it. Which is kind of what I want to do. And then what I'll do is I'll change that request to delete, send it, get a content back, go back to my browser, and in a second that's going to disappear. There we go, gone back to bad gateway. So again, I've spun up an instance which had my application in. You saw it redirect to a different URL before to log in. That had Postgres, RabbitMQ, Redis, and 5 or 6 different applications written in .NET. Spun them up in about 30 seconds or so, and did something, so I browsed to a URL to see if it was 401, and then I deleted it when I was done. So you can imagine a test doing that, right? Or I can anyway, because I'm not very creative. So, yeah, you saw me make a web request to a web service somewhere in Postman. That was to create the instance. That deployed our application to Kubernetes. I made a request to an API endpoint, which had a real database, a real message queue, and a real cache. That 401'd, that's what I wanted to do. And then I destroyed it. So, this might annoy people, it might not, we'll see. I manually did things by following a script that I wrote. I wrote in those slides that I was going to do these things, run the application, hit the endpoint with the 401, and then delete it. If I wrote that script and I followed it, so could a computer. So we can automate that. And what if instead of me pushing that send button to create the instance, that was part of our test setup? What if instead of me hitting the API/users endpoint, the test did that and then asserted on the response? And finally, what if the test teardown hit the delete endpoint and destroyed that for us? Which is what I've done. So all the code for this, by the way, is on my GitHub there. It's all in C# at the minute. I'm working on a version of it in Golang as well, because why not? And probably Java or Kotlin or something as well in the future. So you can check it out there if you want to. So, okay, so this is Rider in IntelliJ. Everybody see it? Good, it's absolutely giant. So what we're doing is we're creating a new instance of our Kubernetes deployer, which is, again, test code that I wrote to wrap our HTTP API. I'm deploying the application, and I'm waiting for that instance to be ready. So I'll start debugging it as well. So I'll just wait for this to fire up, and we'll see it kind of real time. This is a bit where the Wi-Fi goes down or something. Cool, right. So we knew up a thing with configuration, we deploy the application, and then we're going to wait for that to be ready. So you saw in the browser when I kept refreshing it, it takes about 20 to 30 seconds, depending on what else is going on. At times we just wait for it to be healthy. So when no tests are running, which unfortunately isn't on a Tuesday afternoon, it takes like maybe 15 seconds to do. When there's lots of things going on, because it's not a particularly powerful cluster, it takes a little bit longer. So we'll see in a second, hopefully that drop down or fail, one of the two. Can everybody read the code, by the way? Does anybody need anything explaining whilst we're waiting?
I was just going to ask, you said you changed your mind.
Yeah.
So was there one particular thing that changed your mind? Or was it
Yeah, I started using it and learnt it really more than anything. It's more, I had this kind of opinion that this hips that you don't need it, and then actually once you scratch beneath the surface, and you see a lot of intros too. Once you get past all of that nonsense and actually start using it, you really actually see the value in it and how you can use it to solve your own problems. Cool, right, so that has deployed our application for us. The colors aren't great, sorry. And we can see that the deployed URI is CM whatever, something. And then again, we're going to make the same web request as I did before, which is /API/users. And we can see that the status code again is 401. So everything I did in the browser manually, I've scripted in an actual test that is now going to pass because it does what I expected. It's passed, the assertion has come back as equal as true, so nothing's broken, and then we delete it when we're done. And that's it. And then we'll see a little green tick because the test passed. Yay. So, a question I get quite a lot when I do this is that I'm kind of creating an instance and deleting it in the test. Is that what I'd normally recommend? The answer is it depends. If you need to change a lot of state for that one test, then probably. If you can get away with sharing that instance across multiple tests, so you have kind of shared setup of creating a load of data in there and then asserting on the results on a read, then absolutely share it. It'll be way quicker. Okay. Cool. So, if you want to learn more Kubernetes, because I've not really touched a great deal on it because of the time, there's a couple of books I'd recommend. The first one is Kubernetes Up and Running by the people who literally wrote Kubernetes. I normally have a copy of this to give away, but I don't today, so unlucky. And another resource I'd recommend as well is Cartacoda. Has anybody heard of Cartacoda? Yeah, it's a really good resource for learning all of this sort of stuff. Essentially, you can do things in Kubernetes in your browser that will affect a Kubernetes cluster that you don't have to worry about and control. And it's all free, so really check it out if you're interested in learning more. One thing I would say as some lasting advice to all of you is if you can run this in a cloud environment, so one of the pre-configured Kubernetes cloud things, do it. If you have to do this on premises and kind of configure it all yourself, you're going to have fun. So try and aim for cloud if you can. I mean, we don't. Everything we do there was on premises, but you can do it too. But I'd really recommend cloud. It's got a way lower barrier to entry because it's very Linuxy and, you know, I think personally unnecessarily complicated to get it up and running locally well. And with that, I would like to ask you all for some questions if you have any, and thank you. Yes?
Talking about the logs and everything being very centralised, is it like a real-time view of the logs? Sort of like data coming out to them?
Yeah, you can have a real-time view. It's going to Elasticsearch and then they're visualized by Kibana. So it's posting them to Elasticsearch in essentially real-time. There may be like a bit of a delay because of network latency and things. But yeah, they're going in instantly. So you can visualize it real-time with Kibana and things, yeah. Yes?
So which of the big cloud providers do Kubernetes can do it well?
They can all do it well. None of them are paying me, so I don't have an opinion on them. I mean, Google has been going around the longest with Kubernetes, and Amazon and Azure is much newer. So maybe Google, I don't know. It's more established. It doesn't make it better though. Any others?
Cool.
Yep. Yep. You then you. Yes.
So were your tests flaky in any way then? No.
No, because once it's deployed, we have an environment that we can run against. It's like running it anywhere.
And also we've used AKS and it's kind of not as stable as you want. So I don't know if like the environments that you have on-prem were very stable. Do you have any problems with the cluster?
On-premise, it took us like 6 to 7 months to actually get it up and running with a lot of fiddling around. That's why I was recommending the cloud. We deployed it to the cloud and it worked instantly.
So do you use the same cluster where you have your testing stands for your own running of the test? Or do you have and you just run your test in a different namespace? Yeah,
so each test is in a different namespace. Each time we deploy it, it's in a different namespace. So if I go to here, you can see, so forget the namespaces, hopefully this works. Yeah, you can see it's cut off a little bit, but all of these here are different tests that are running currently in a different namespace, different number. So they're all running currently. So there's 1, 2, 3, 4, 5, 6 running there at the minute.
And one last one. How many containers would you say you spin up for a test?
I mean, it keeps growing, so we keep adding more to our application because we decided to run our monolith as microservices. So anywhere between like 8 to 11, 12, but it depends on how much resources you have really. But yes. Oh, okay, yeah. Yeah, so it depends. There's no upper limit, there's no lower limit. There are people using Kubernetes with, you know, hundreds and hundreds of containers running in there. There are people running Kubernetes with 1 container in there. Those people are dumb. But there's lots more.
Cool. Thank you, Joe.
Cool, thank you.